When I was a kid, I loved milk. So one day I decided to cut it in half with water. It tasted good. So I decided to cut it again in half with water. It still tasted good. This looked like I was going great guns. But after the third or fourth time, it started tasting ugly. This is what math is like today. It's watered down. It's lost all the beauty and the substance it did in the rich form when I was a kid. One of the things which I learned was challenge everything that you're taught. This was not too difficult because I was a little bit rebellious when I was younger. But this is good advice when learning math. So let's start off with something simple. Let us begin by challenging what we learned about zero. Like 0 plus 3 is equal to 3. And the answer a lot of us were given when I was a kid and still today is that the reason why that's true is because 0 is nothing. But if I go to a clock, 3 plus 12 on the clock is also 3. And 12 is definitely not nothing. Well, after people hem and haw trying to explain this, I said, look, how do we make our numbers? We add 1 to the previous number. So 2 plus 1 is 3. Therefore, 0 plus 1 on the number line would be 1. And 12 plus 1 on the clock would be 1. That's a consistent definition. Now, what makes it interesting is if we take and raise 2 to the 0th power, we'll find that's also 1. And 0 factorial is 1, even though 0 factorial implies multiplication. So, telling us that 0 is nothing gets us into a lot of trouble when we get into upper mathematics. Now, let's challenge our knowledge of fractions. Let's take another topic. What is a fraction? Well, what fraction of a year is 1 month? And what fraction of a year is 1 week? And the answers that I'm usually given is 1/12 and 1/52. When we learned fractions, we told that all the parts had to be the same. Which month are we talking about? January of 31 days or February of 28 days? In fact, if we divide 366, a leap year, by 12, we get 30 and a half days. Which month has 30 and a half days? And if we take 7 and multiply it by 52, we get 364. And in a regular year, there are 365 days. So something went wrong when we were being taught fractions. In fact, most people can't even tell us what the definition of a fraction. I found a convenient definition is when a unary fraction is multiplied by its inverse, which is the denominator, we get the identity element for multiplication as a result. Let's take and see what happens when we really start understanding and go beyond and challenge what we learn. I multiply these two mixed fractions together. I can do it without using a calculator or doing long arithmetic on paper. I can do it all in my mind. I'm just making use of the distributive property. Over here, if I do it the way I was taught, I convert the fractions to mixed fractions to improper fractions, multiply the numerators and denominators. But the numerators can't be multiplied easily in your head, so I have to do it on paper, and the division can't be done easily, so I have to do it also. I could also use a calculator to do it, which would give me even less feel for what's going on. I can do this faster than you can put the numbers in a calculator. Mental arithmetic is important. We talk about it, we just give it lip service. Here is really using mental arithmetic to its most effect. And what we find is when we understand the basic properties of mathematics, we can use them and do something very interesting beyond what we were taught. Now, since we know that division is reverse multiplication, if we take the definition of fraction, we find a fraction, a unary fraction, is equal 1 divided by the denominator. So, multiplying by 1/2 is the same as dividing by 2. In fact, kids are on that definition, but quite haven't made it there. And finally, we challenge what we were taught in geometry. What's the definition of a straight line? When I was a kid, we were taught it was the shortest distance between 2 points. Today, I'm not sure what the kids are taught. They really can't give me a definition. But we were never taught what that meant. It meant that only one straight line could be drawn. If we could draw another straight line, then it would overlap that first line. And that uniqueness allowed us to prove the theorems in geometry without us ever realizing it. Now, the other thing that's important about straight lines is, here I've shown an angle. If I take a protractor of any size, I will get the same measurement angle. But if it's not a straight line, if I change the size of my protractor, I will get different answers. And here you can see with this, I'm going to get a bigger angle than I would for a straight line. In fact, one of my favorite tricks with the kids is to give them a triangle that has slightly curved surfaces and have them measure it with a protractor. First they learn they don't know how to use a protractor, but then when they finally get to use it, they come up with the sum of the angles is 210 degrees. They're willing to accept that the 180 degrees that they were taught was incorrect. What's happening to reasoning and logic? This is my favorite. What are parallel lines? Kids in the second grade are taught to put their hands up like this and say they're lines that never meet. Well, to find out if we never meet, we have to go to infinity. And it's a long way. We may never get back. When I was a kid, we were taught there was two lines that made the same angle with the third line. And we could actually take a draftsman's kit and we could draw parallel lines. Okay, so what we find is that if we learn how to recognize patterns and try to organize the stuff that we learned, we can actually be able to find explanations for these patterns and begin to understand what we've learned. And it makes it easier to study. Manipulatives have always bothered me because I found that when kids would come to me and learn their arithmetic using manipulatives, they were having trouble. When they used the techniques I used, it was easy for them. And when I talked to educators, they thought manipulatives were great. I finally discovered what this answer was. Manipulatives should be used after you've learned this stuff to validate it, not before to teach you. Hopefully I've made my point that we're teaching nonsense a day. If not, our children are not understanding or misinterpreting what we're saying. So let's see what we can do about that. Well, the first thing is I started questioning children, and I asked them if they talk to themselves. A lot of them said no. Well, talk to yourself, that's thinking. They've got too many things, they don't have time to think. So we've got to change culturally how we deal with things. And then we're dealing with technology. Calculators, we don't get a chance to get a feel for the number because we just put the numbers in and get an answer. Calculators are good after we've learned this stuff. So there's a lot of simple things that we can do that can make a world of difference. And I know firsthand because I've done that with hundreds of kids. Here at the Math Museum, the Math and Physics Exploration Center, and in several of the major school districts in the county. Thank you for giving me your time.